announcements, quick announcements. So I haven't really checked the names for those who cannot make it for 5th October or 7th October. So tomorrow is the last day. So after tomorrow, I'll check the list and we'll start to contact you guys who cannot make it for good reasons for these 2 sessions. Okay, then we'll look for another slot for makeup. Okay, so the URL is in the e-learn announcement. Second announcement, lab test, all right, which is worth 10% of your grade. So we are both very worried about lab test. Okay, but don't worry too much. 2 hours, maximum 4 hours. In other words, it's actually meant to be completed around 2 hours, within 2 hours. So this is 2 weeks later. You should start preparing for it. Submit solutions to the rate server during the test itself. The last submitted solution will be the one that will be considered, be marked. So before you leave the room, check all the scoreboards before leaving. That means your name is there, your score is there, name, score, name, score. It's open book, open laptop. Please bring your laptop, okay, because I don't have a laptop for you. One is enough. I know some will bring 2. You can use the internet, it's important. So we do not want you guys to memorize anything. So you can use the internet to search how do I extract one element from from the list, but you should know that actually, right? So you can use the internet, but during the test itself, no communication, direct or indirect. So I give an example. You cannot send emails, you cannot send messages, Telegram, WhatsApp. You cannot post a question on the forum and hope someone on the other side of the earth will answer within 1 hour. That kind of thing. No one. In other words, you can actively post questions. You can read what is available. And some of you may think of this idea, wow, share a folder on your laptop, then people submit your folder, that kind of thing. No, not allowed. All these are forms of communication. So basically, you do your own stuff, but you can use the internet. All right? We are trying to make it such that as real life as possible. When you go out to work, you'll be using internet to search for certain things. Now, Lab 1, I only have 2 slides for you guys. I just want to emphasize again, there's a difference between a function returning something and a function printing something. So this one, the function is called square. It returns whatever is passed in to the power of 2. All right? There's nothing printed out. Now, the one on the right, on the other hand, is different. It prints something and does not return anything. So Python allows you to write a function which does not return anything. There's no return something. When you call square, it doesn't return anything. Okay, it doesn't even return none. There's a difference between none, which is a value, and nothing. I don't know how to describe nothing. It's not none. Okay, if you try this thing on the right, answer equals to square 10. You realize that nothing is stored in answer, not even none. You can try ANS enter, nothing appears. Not NONE, that's the difference. So just be very careful when you are asked to write a function which returns something. Don't print anything. The function computes a value and returns the value. Don't print anything. Okay, for your lab test, it's similar to your lab exercises. You are supposed to write a function to do something, computation, whatever, and return a value. Okay? The caller of your function will decide what to do with the return value. The caller may decide to print it out. The caller may decide to store it somewhere, may ignore it. This is not your problem. Your problem is just to compute using algorithm or whatever and return a value. Okay? Don't print anything. We won't usually ask you to print anything. Now, another point which wasn't covered in week 2, some of you who are new to Python may find interesting that in Python functions can return multiple values. So a simple example here, the test function returns something, comma, something. Okay, something, comma, something is not a list of 2 values. Something, comma, something means 2 distinct values. It's not a list. A list is 1 item. So now it returns 2 values. And you can do something like a comma b equals to test 6. And 6 to the power of 2 will be stored in A. Alright, there's 6. And 6 to the power of 6, which is 46656, will be stored in B. Okay? You can write a function which returns n values, no problem. So you have a comma b comma c or whatever good variable names you prefer to use. So this is possible because I want to show you guys this because the project requires to write a function which returns multiple values. So it should be quite straightforward this one. Okay? Interesting for Python. Java, no such thing. Okay, Lab 2, very interesting. Some of you come and came to ask me, how come these people can actually manage to do it in less than 1 second on the scoreboard. Okay, so I'm going to go through 3 different ways to do 2A here. One which takes, okay, these numbers are from my laptop, which is not very powerful, okay, from my laptop. So what I gave you, ON sequential search, to check whether a particular ID exists or not. Let's go down the list to check one by one. Is it this ID? No. Takes about 6 hours for 500,000 random calls on my laptop. Okay. Now there is Python has this in operator. Requirements say don't use the in operator. Okay. If you use it, you take about 2+ hours. Still very long. Okay. Now most of you, I'm expecting you guys to actually read about binary search to do it. You take about 8 seconds on my laptop, all right? And some of you managed to do it in less than 1 second. And how is it done? I'll explain this very, very soon. So I just want to show that you can use the in operator, but it is very slow because what happens is that I believe I won't bother to check the source code for Python, but I believe that this in operator goes through the lists, employee list in this case, and check one by one. You check whether ID is found at position 0. No. ID is found at position 1. No. ID is found at position 1. Okay. It's still an ON operation, but it is much faster than the code I gave you. It takes less than takes 2 hours. Why? Because it is written in a very optimized way, but it's still slow. Okay. So you should not do that. Now binary search how? It's a log n algorithm. So you don't touch perform once, but you change the exist function so that now you perform a binary search. Now the original binary search I gave you the code, right, returns index or none. Index if it's found, it means the position, where is it found, or none if it can't be found. So you have to change it. You can't just copy wholesale, you have to understand it. So now if it's found, return true. If it's not found, return false. That's it, that's the change. Okay? And this is a log n algorithm where n is the length of employee list, number of elements in the list. Okay, so this will work on the server within the time given. Now, what about these people who crazy can do in less than 1 second kind of thing? So they use an O1 algorithm. So it's not even dependent on the size of the list. Okay, before talking about that solution, before showing you code, right? By the way, I don't intend to release the slides and the source code now. Anyway, this recorded will be posted. Because I want you all to type it out. Then you will get errors if you want. Instead of just copy and paste. So what is a set? A set is similar to a list. Okay, except for 2 differences. Number 1, sets are unordered, meaning that a list, A is at position 0, B is at position 1, and so on. In a set, the elements are not ordered. There's no concept of this element is in position 0, is at position 0. The second difference is sets may not contain identical elements. So this set, if I try to insert E again, and E is already in the set, the second E will not be inserted or basically these 2 E's are only one of them will appear. Okay, you cannot insert an element in the set if the set already contains it. Another way to look at it is that only one of these 2 elements will remain the set. Okay, you can see some examples here, how to use a set, create a new set here. I call an add function, pass 3 in. I call add function, pass 3 as a string. There's a difference. This is an integer, this is a string. And I pass true in. So altogether, there are 3 elements in set. If I try to call add and pass 3 in again, you realize that there are still 3 elements. Alright, because 3 already exists. There won't be an error. There won't be an error. So sets are designed to work like that, so that if you add in something which already exists in a set, nothing will happen. The length of S will be 3. Okay, so there are 2 other ways to use to create a set. So this is one way. During the creation of the set, you actually pass in certain elements already. Now this is the other way. I have a list, and during the creation of the set, I pass in the list. So basically, all the elements in the list will become elements in the set. So if there are duplicate elements in the list, which is perfectly fine, okay, you realize that the set may have a fewer number of elements compared to the list. So duplicate elements will just be removed. Okay? So you can't do this for a set because it doesn't make sense. What is at position 0 because unordered. You can remove elements from a set. Okay, S dot remove 3. You cannot remove based on its index because no such thing as index for a set. Now, this is interesting. Like a list, you can actually do value in set. So you return true or false. Alright? Now the another difference between a list and a set when you actually check whether something is in a list or set is this. Checking if an element is in a list is an OM operation. Slow, okay, which I've showed you, it takes 2.2 hours if n is that large. N is 1 million and call that function 500,000 times 2.2 hours on my laptop. However, for a set, if you want to use the in operator, 99 in my set is an O1 operation. Now what does that mean? Does it mean that this operation will be very fast? Probably. What it means is that this operation does not depend on n. It means it does not depend on the number of elements in the set. So your set has 1 billion elements. Okay, 99 in my set will take roughly the same amount of time as if you have 1 trillion elements in the set. Okay, that's different. That makes a huge difference when compared with a list. All right. And how is it achievable in a set? Why is it an O1 operation, not in the syllabus? Go and find out more if you're interested. Because a set uses what we call hashing functions to determine if a particular element is there or not. Hash functions are out of scope. I can find out more by myself. Just do a search for hash functions. If you're familiar with, if you've heard of this term called hash tables or hash maps, right? Same idea. Okay, a set in Python is similar to a hash table, hash map. A dictionary as well. You should talk about soon. So only 2 lines of code. Perform once is changed. Instead of returning the list, it now creates a new set, dumps the employee list inside, and returns the set. And the exist method, which gets called 500,000 times, is an O1 operation. Just return ID in employee list. Remember, employee list now is not a list, it's a set. That is why if you call this function 500,000 times, it takes less than 1 second to return. Even if employee list, which is now a set, contains a huge number of elements. Okay? So I don't expect you guys to know this 2 weeks ago, but now you should be able to use sets to your advantage if you want to. Okay? Now 2B, same thing. Some of you managed to do it very quickly. Some of you minimally map the timeout stipulated on the server. So sequential search was the minimal standard I expected. Sequential search, you go through every element in the employee birth year list. You compare the year. If it matches, add the ID to a list and then return the list at the end. 3.4 minutes on my laptop. Okay, let's take a look. This is at the very least I expect. Okay, and this will work on the server within the timeout given. So basically, create a new list called match, whatever, answer. You go through one by one. For I in range 0 to length employee with birth year list, and then you compare the current year, is it the same as the year looking for? If so, append the current ID to the list to be returned. You keep repeating this ON, where n is the number of elements in the list. Okay, this one really ON. Because worst case ON, best case ON, average case ON. Okay? Because you really go through every element. And then at the end you return. Now, some of you all were thinking of using binary search. How can I use binary search for this? Yes, but you have to modify it a bit, adapt it a bit. This will take about 23 seconds on the laptop. It's a log-n algorithm. How? Now, binary search works only if the list is sorted. Unfortunately, the original list was sorted by ID. No good, because we are not searching by ID, we're searching by year. So before doing binary search, you have to sort the whole list again by year. Okay, so after sorting, this example here, after sorting you have, instead of the ID in front, so 199, 199, 199, 199, 2000, 2000, okay, this simple short example. And the answer you want is actually 4, 2, 7, and 12 are the IDs of the people born in the year 1999, assuming you are searching for all the people born in 1999. So once you have done the sorting, you can do binary search. Now do binary search, you will always return, in this case, the index. So let's say the index 2 is returned. what do? You can't just take the ID 7 and return it, because that's not what we want. We want 4, 2, 7, and 12. You cannot ignore 4, 2, and 12. So you need to do more work. What work like? From the midpoint, it means from the matched index, you sweep to the left. Because you know that all those 1999 people are on the left and on the right. They are already sorted already. So you don't go and redo a binary search again. All you have to do is use a loop, check the one on the left. Same birth year, okay, good. Add ID into the list to be returned answer. Go to the left again, check birth year, same ID, same birth year, okay, add 4 to the list to be returned. Then sweep to the right, do the same thing. Same birth year, add 12 to the list of IDs to be returned. Check this one, same birth year, no, so stop it. Okay, because you know all the 109s are clustered together, and your binary search will definitely return one of these, the index of one of these 4. So the code looks something like this. This is a normal binary search. Okay, no more return true or false, returns mid and returns none. Alright? So perform once, which is called only once. Just sort the list by year. Now this is likely to be n log n sorting algorithm. Okay, you may think, well, n log n not very good, but remember, perform once is only called once. Get IDs with birth years the one called many times. Alright? And this one, so 3 parts, you perform a binary search. We check if index is none, just return an empty list. That means no one has this birth year. Otherwise, I append the current ID to answer, and then I sweep to the left. In the process, I keep checking. If there are matching years, I append the ID to answer. Okay? And then I sweep to the right. Now, very important thing, we must make sure that I doesn't go beyond, that means go to the left of 0. So you keep checking to the left until either the year does not match or I reach the leftmost boundary. Once I is in -1, you stop. Same thing when you sweep to the right, make sure that you stop when I reach the rightmost boundary. Otherwise you get the error. Okay, lastly, using a dictionary. 30 more seconds. Okay, using a dictionary. Again, this is an O1 algorithm, that's why it takes so little time. And what is a dictionary? Something like a set, but it's a lookup table. Each row in the lookup table has a key and a value. So it's like a telephone book. Okay, the key is unique. It's like your student ID, unique value is your name. Now dictionaries are very efficient when you want to use it to look up the corresponding value using a key. It's an O1 operation. How is it achieved? The hashing function stuff. So I'm not going to go through this. You can try this in idle. But just take a look at it's key colon value, key colon value, key colon value. And the key doesn't have to be an integer, it can be a string as well, it can be anything like that. Okay? Now, for 2B, think about it. If you have a table, a dictionary which looks like this, the key is the year of birth, the value is the list of IDs born in that particular year, then the answer, the function can be as simple as if the year is found in the list, this is the dictionary. Just return the value for that particular key. So the key is the year now, and this is O1 operation. It's very fast. So now the problem is to create the dictionary. This is the way to create the dictionary. So you go through all the elements in the list, and you keep inserting the value into the dictionary. If this row already exists, that means a particular year already exists, just take up the value, append a new ID, put the value back. Okay? Basically, you are actually changing the value. If the year does not exist, the row does not exist, I create a new row. The year is the key, the value is a list with one ID only. Now this is an ON operation, but remember this happens only once. This function is the one which gets called many times. Alright? Now I probably don't have time to go through this, just take a look at this yourself. The way you write your code affects performance. Okay? So then we'll play the video, you pause here. Okay? So another example here, again, you watch the video, you pause here. Alright? trying to show you this part here is that there are two things which affect time performance of your code: the algorithm chosen and how you write your code. Unfortunately, how you write your code affects the time your code takes. But for this course, we are more interested in the algorithm chosen. So if you choose a log n algorithm, is definitely better than a O n algorithm, especially the function, the one which gets called many times, half a million times. Okay. Now this lab is not scored, but if this lab is scored by performance, you'll be ranked by time taken and you'll be given points. 5, 5, 4, 4, 4, 4, 3, 3, 3, 3. Lab 3, try to finish it by tomorrow, submit by tomorrow or latest Wednesday. Lab 3 is interesting because now we look at quality of your algorithm, not only time. And Lab 4, which I've just released, has got to do with recursion. Okay? So that's all. Thanks guys.